Using zero and negative exponents. We're going to start by filling out the chart on the top right-hand corner. It's asking you to use exponents in order to find the different values. Remember that an exponent with a base of 2 and an exponent of 3, this is your base, and this is your exponent. Okay, it's having you fill in your chart. So 2 to the third power means that you're taking 2 times 2 times 2, which gives you a value of 8. So let's go ahead and fill that in on our chart. Okay, the same thing is true for the next one. So 2 times 2 gives us 4. 2 to the first power is 1. If you use your calculator, you'll find that 2 to the 0 power is 1. 2 to the negative 1/2 power is, or 2 to the negative 1 power is 1/2, and 2 to the negative second power is 1/4. Okay, if you continue to fill in your chart, you'll hopefully begin to see a pattern that from 8 to 4, we're dividing by 2, and the same is true as we go from 4 to 2, from 2 to 1, from 1 to 1/2, and 1 to 1/4. So let's take a look at 4 to the third. 4 to the third would be 4 times 4 times 4. 4 times 4 times 4, which is 64. 4 squared is 4 times 4, which is 16. 4 to the first is 4. So notice we're dividing this time by 4 each time. So we have 1, and then 1/4, and then 1/16. So you would imagine then that as we move over to the 5 to the power of 3, okay, we'd have 5 times 5 times 5, which is 125. We'd have 25 for 5 squared, 5 for 5 to the first, 1 for 5 to the 0 power, 1/5 for 5 to the negative 1, and 1/25 for 5 to the negative 2. So each time we're dividing by 5. So notice that as you go down in exponent, you divide by your base over and over and over again. As you go up in exponent, for example, if we wanted to find 2 to the 4th, okay, we're going to multiply by an extra 2. So 2 times 2 times 2 would give us 16. Okay, so exponents, you multiply to go up in exponent, and you divide to go down in exponent. Please pay close attention to the fact that your negative exponents did not make your number negative. It just made your value move to the bottom of your fraction bar. Okay, let's go ahead and take a look over here on the left. So the pattern as you go down the chart is that you are dividing by the base. Okay, now you'll also notice if you take a look at your chart, anything to the 0 power, no matter which base you had, 2, 4, or 5, you ended up with 1 as your value when 0 was the exponent. This is true of any number. Anything to the 0 power equals 1. 3 to the 0 power is 1, and then a to the 0 power is also 1. No matter what that value is, if we took 10,000 to the first, or to the 0 power, that would also equal 1. All right, let's take a look at a couple of examples. So 4 to the 0 power, we just talked about how anything to the 0 power is 1. So if we take 4 to the 0 power, we're going to get 1. This entire thing, because it's in parentheses, it's all being taken to the power of 0, which also gives us 1. As we add in values, so for example, in our next one, we have a 2 on the top, which is going to stay, and then 5 to the 0 power, we said anything to the 0 power is 1, that's going to be 1, and then we can divide. So our simplified value is 2. In number 4, b to the 0 power, anything to the 0 power is 1. Our 6 stays the same, and that's as simplified as we can get. 1 and 6 don't simplify any further. So the big thing to remember in that first part is that anything to the 0 power is going to equal 1. Let's take a look now at negative exponents. Okay, we saw this a little bit at the top when we were dividing. Our power goes down each time we divide by the base. Having a negative exponent on a base like 4 means that you have a very small number value. For instance, with this 4 to the negative 5, it's moving it to the opposite side of the fraction bar. So we have a 1 over 4 to the 5th. Notice as it moves down to the opposite side of the fraction bar, your exponent becomes positive. So we have 1 over 1024, which is a very small decimal, 0.00098. Therefore, if the base is given with a negative exponent, you will be asked to convert it by using this formula. So a is our base and n is our exponent. Okay, the negative exponent, it's kind of like your elevator button. It tells you that you want to move to the opposite floor. So we take it and move to the bottom. The reverse is also true. So let's say you started out with a 1 over a to the negative n. That negative exponent on the bottom tells you want to move it to the opposite side of your fraction bar. So that's going to become an a to the positive n. Okay, and you can put your 1 over that. So if you look at arithmetic, and all that means is that you have a number, 3 to the negative 2, that negative exponent tells you to move it to the bottom and make that exponent positive. So we'd have 1 over 3 squared, and we know what 3 squared is, so we can change that to 1/9. Okay, with the algebraic, that just means you're doing this with a variable, but it works the same way, that we have a to the negative 2nd, so that negative exponent tells us to move that a squared to the bottom, and as we do that, our exponent becomes positive. So let's look at several examples of how we can simplify based on the rules that we just talked about. So one of the important things to pay attention to is whether or not there are parentheses. If there are no parentheses, the exponent goes just with the value that you're looking at. So for example, this negative 1 or negative 5 is really negative 1 times 5 to the negative 2. So your negative 1 is going to stay the same, but your negative exponent on your 5 tells you to move that to the bottom and make that exponent positive. So now we've got negative 1 times 1 over 5 squared, and 1 over 5 squared is 1 over 25. So we get negative 1 over 25. So the negative was separate from the value with the exponent. In number 6, we just have that negative exponent, which is our elevator button. It's telling us to move that to the bottom of our fraction bar. So we end up with a 1 over 84. So that one was pretty simple. We just move it to the bottom, and then since it has a power of 1, you can either leave it like that or you can put the power in there. Number 7 is similar to the one that we just did here in number 5, but notice the difference. Now there's a set of parentheses around that negative 4, which means that the negative is part of what's being squared. So our negative exponent tells us to move that down to the bottom. So we've got a negative 4 squared, and as we move that exponent to the bottom, it becomes positive. That's what our goal is to get all positive exponents. So now we've got 1 over, and then we've got to take negative 4 and square it. So that's negative 4 times a negative 4, and we know that a negative times a negative is a positive. So that's going to be a positive 1/16. So in number 5, the negative was not part of what was being squared, but in number 7 it is because of those parentheses. Okay, parentheses are something that it's important to pay attention to. All right, if you take a look over here now at number 6, the negative exponent is telling us to move that down to the bottom. So we're going to take 1 over 1.5 squared. So as we move it to the bottom, it becomes positive. And then if we use our calculator, we'll see that that would be 1 over 2.25. In number 7, there are no parentheses. So as we look at this, it might be a good idea for you to split it apart because each of these is individual. So if I put a multiplication sign in between each one, I've got 3 times m times n to the negative 1. I've just rewritten it with the multiplication signs there because what I want to show you is that the 3 and the m are going to stay the same. They're unaffected by that negative exponent. It's just the, oh here, let me erase that. It's just the n to the negative 1 that's going to change places. So the 3m stays up top, but the n needs to move down to the bottom. So the question you want to ask yourself is, what gets to stay, what has to move, and when it does move, okay, what's that value going to be? So in this next one, in number 8, we've got 4 times x to the negative 2. I'm rewriting it so that I remember it's not the 4 that's being squared, it's just the x. And the x with the negative exponent, that's what's having us move to the bottom. So the 4 gets to stay, but the x squared moves to the bottom and becomes positive. Okay. In the next one, number 9, we're looking back at our 0 exponent rule. We've got a g times an h to the 0 power. And we know that anything to the 0 power is 1. So g times 1 is just g. Okay, so be careful. It's not the whole thing that's taken to the 0 power. It's just the h to the 0. So that's 1. And then we still need to multiply by g. Something similar happens in number 10. 2 to the 0 power is 1, because anything to the 0 power is 1. And we've got an a to the negative 3. And that a to the negative 3 tells us we got to move our value to the opposite side of the fraction bar. So in this case, it's on the bottom, which means that we want to move it to the top. And as we do that, it becomes positive. In number 12, let's think about all the things that have to stay. Anything that has a positive exponent stays. Anything that has a negative moves. So your 3, your m, and your a, none of them attached to a negative exponent, all stay where they are. Your x has a negative exponent, so it has to move to the opposite side of the fraction bar. So it moves down here, and your exponent then becomes positive. Your y to the negative 3 moves to the top in order to make that exponent positive. And then there's nothing else there that's going to simplify, and so we're going to leave it just as it is. Okay. Let's take a look then at number 12. In number 12, your 5 and your w are not attached to negative exponents, so they're going to stay where they are. But the m has a negative 7 exponent, so it's on the bottom, so it has to move to the opposite side of the fraction bar, and as it does that, it becomes positive. So there's nothing else there that we can simplify. So think about what has to stay, what has to move, and when it does, whether that exponent should then be positive or negative. All right, 2 last ones. Simplify and then evaluate the expression. Okay, it's telling us r to the 0 and s to the 3rd. We know that r is 4 and s is 3. So the first thing that we want to do is plug in. So r to the 0, so we've got 4 to the 0 power. Notice I put it in parentheses, okay, and that I do in case there's a negative, I know that I include it, times s, which is 3 to the 3rd power. So let's evaluate. That just means to find out what those numbers are. We know that anything to the 0 power is 1, and we know that 3 to the 3rd power is 3 times 3 times 3, which is 27. And so if we multiply, we get a value of positive 27. So we plugged in what we knew for R and S, and then we simplified our values. All right, number 20. Number 20, again, they tell us our x and our y, so we're going to go ahead and plug those in. X is 8. It has no exponent. Y is 2, and it has a negative exponent. So remember, things with positive exponents, or in this case, think of this as being a 1, we leave that alone. So the 8's going to stay where it is, but the negative exponent on the 2 means that we have to move it down. So this becomes a 2 squared. Okay, and then now we can continue to simplify. So 8 stays on top, 2 squared is 4, and then we can simplify and get a value of 2. Okay, so remember that in this lesson we talked about how anything to the 0 power is 1, and that a negative exponent means that you move that value to the opposite side of your fraction bar, and then as you do that, it becomes positive. You would now want to complete the practice assignment for section 7.2. Thank you.